You are walking through a room when a faint wisp of vapor hits your nose. Within a fraction of a second, a heavy wave of nostalgia washes over you as your brain reconstructs an entire winter morning from 20 years ago. Vision and hearing rarely operate with this kind of speed. When you look at an old photograph or hear a familiar song, your brain processes the raw data first, identifying the object and the context before the associated emotion begins to surface. Psychologists call this the Proust effect. It represents a unique reversal of our typical sensory order, where olfaction triggers intense emotion and a visceral bodily sensation before the conscious mind can even identify what the odor is. This immediate authority over our physical reality seems strange for an invisible chemical signal. To understand why it happens, we have to look at the specific wiring beneath our skulls. Most sensory data follows a standardized route. Every time you look at a tree or listen to a conversation, those signals navigate a multi-layered biological checkpoint on their way to your conscious awareness. This schematic shows the thalamus, the brain's filter. Visual and auditory signals stop here to be evaluated. But watch the smell pathway. It completely bypasses this bouncer, plugging directly into two ancient structures: the amygdala, our emotional core, and the hippocampus, our memory drive. This anatomical exception is the reason a familiar scent forces us to experience a deep feeling before we can even articulate the name of the odor. Evolution prioritized this neurological shortcut because for early mammals, waiting for high-level cognitive analysis during an emergency was often fatal. Immediate, unthinking reactions were necessary for survival. The smell of smoke needed to trigger instant fear. The odor of biological decay had to trigger immediate disgust. Emotion provided the fastest possible mechanism for a life-saving response. For many animals, this emotional chemical mapping remains the primary interface with the physical world. A bloodhound following a trail is essentially navigating a landscape defined by chemical and emotional data. As humans shifted toward visual and linguistic dominance, we kept this primitive alarm system. However, we began using it for a different psychological purpose: the preservation of our personal history. During childhood development, the brain uses this survival hardware to link repeated, safe smells to our deep attachment systems. This creates distinct odor landscapes. Different geographic and cultural regions develop their own sets of chemical triggers that the nervous system interprets as safety, nourishment, and home. In a vibrant Mexican market, the aroma of fresh corn tortillas and regional spices functions as a biological anchor, instantly pulling childhood identity and family rituals into the present. Other cultures use different catalysts: the steam of a traditional tea ceremony, the scent of wood smoke, or the aroma of fresh bread carries the emotional weight of family and long-standing rituals. Within the brain, these smells act as global attractors. A single odor reactivates an entire experiential atmosphere, encompassing the temperature of the room, the cadence of distant voices, and a specific bodily feeling of security. This evolutionary wiring makes smell the deepest biological anchor to our cultural identity and personal history in the waking world. While we are awake, the prefrontal cortex, the brain's logical manager, forces these emotional activations to remain realistic and strictly tied to our autobiographical past. But during REM sleep, the rules of the Brain Kinematics Model take over. Our reality-checking logic shuts down, while the emotional limbic system remains highly active. Because smell completely bypasses normal sensory gating, a mild odor drifting into a room won't wake a sleeper. Instead, it slips past the body's defenses and plants an emotional seed directly into the dreaming brain. Once the odor is stripped of waking logic, it becomes an unrestricted catalyst, silently hijacking the brain's narrative engine to construct a story around the feeling. Through associative expansion, the sleeping brain translates the smell's raw emotional strain into a surreal narrative rather than literal imagery. The smell of wood smoke during sleep might not produce a dream about a fire. Instead, it taps into ancient alarm circuitry, expanding into a scenario of urgency, conflict, or an impossible escape from an unseen threat. Conversely, floral scents often expand into emotionally resonant dreams of family reunions or an illogical nostalgia for places that no longer exist. Smell is our most intimate biological tether. It anchors our waking reality to the past, while invisibly directing the surreal stories we inhabit every night.